Hi, so welcome to a case study, and which is towards the end of this particular module, where we have looked at multiple advanced dimensional modeling techniques, many various advanced dimensional modeling techniques. So it is now time for us to see how these techniques can be actually used in modeling. And for that purpose, I've selected two case studies. One is the academic data warehouse, and the second is banks. So let me first talk about academic data warehouse. So what we'll do is we'll assume the BITS education model, and we'll look at three basic processes in this model. So one is the student registration, second is attendance, and third is performance. So let me give you a little bit of background. Like whenever a student is newly admitted, or he comes back for a new semester, right, he has to register for a set of courses in for that particular semester or term. And we also have a summer term which is run for 2 months, and you can also register for some courses at that time. And then we have the second process, which we call as the attendance process. So here we try to record the attendance of all the students who are coming to classes, right? So any student entering the classroom is counted. And third is performance, like what kind of grades or what kind of CGPA you are maintaining at the end of the semester or at the end of the program. So now if you look at it, like student registration happens once in a semester, excuse me, and the performance also happens, or performance is also recorded for every semester, right? So let us assume that we are not recording the mid-semester grades. So these are the three processes that we are going to look at in this particular case study. So let me begin by giving certain details. So requirements. So before you set out to design a data warehouse, you need to come up with a set of requirements. So we call it the requirements analysis, right? That is the normal term that we use in software industry, but this is called as analysis requirement, right? So what kind of analysis you are trying to do? Analyze student registration, analyze student attendance, relate attendance to performance, analyze facility utilization. So these are some of the things that I want to do with my data warehouse, and there are a whole lot of things that you can do. You can actually, BITS, like as you know, is a multi-campus university, so you may want to analyze different aspects across campuses, right? So all those things are possible once you have a data warehouse in place. So let me explain the scenario to you. So there are many disciplines in which we offer programs, right? And then there are many departments. Then we have first degree and higher degree students. Then we have multiple campuses. Then we have 4,000 on-campus students in Pilani, and slightly lesser numbers at the other campuses. And we offer around 350 courses in each semester. Each student doing 6 courses per semester and 40 lectures per course. And suppose I want to store 5 years data. So if this is my requirement, right? So, and suppose I'm trying to record the student attendance, right? So let me see, say one course, one course, 40 lectures, right? So suppose there are 100 students registered in this course, right? Or for that matter, let's see, so there are 350 courses, right, in all. So one course, 40 lectures, and 350 courses are offered. So one course, suppose there are 100 students registered in a course, 100 students. So in one course, how many records would be generated for attendance? So 100 students for one lecture, they would come once. For 40 lectures, they would come 40 times, right? So this is for a course. and then you multiply it by the number of courses. So on an average, I'm saying that there are 100 students registered in a course. Multiply it by 350, which are the courses that are offered, right? And so 5 years data, so that means I'm looking at 10 semesters of data, so 10. So this would be the size of the fact table. Okay, excuse me. So 100 students, so you can see it like this. Okay, multiple campuses, 4,000 campuses on students on campus in Pilani. 350 of courses offered, each student doing 6 courses per semester, and 40 lectures per course, and 6 years data. So you can very well see how much data we are generating through this exercise. Analysis requirement. So I want to find out top 5 or bottom 5 electives, so that if there is not much interest in these courses, I can think of dropping them. Correlation between attendance and performance. So this is a very critical question in BITS, that whether attending your classes results in a better grade or not. And variation in MGPA of courses, suppose there is a course which is run by all the 3 campuses or 4 campuses for that matter, and you want to see the MGPA, that is the collective performance of students in a particular course. It comes out of, it is measured along a scale of 10, right? So you want to see what is the variation of MGPA in courses across campuses. So this is another kind of analysis you want to do. And variation in CGPA of students discipline wise or campus wise, so that also you can do, or that is what you want to do actually, right? So average CGPA, MGPA over the last few semesters at different campuses. So you want to do this. Average CGPA means CGPA of all the courses that are being offered in a particular campus, and similarly MGPA also, CGPA of all the students in a particular campus. MGPA means I average the MGPA of all courses that are being offered. Attendance performance in CDCs and first and second year disciplines. So CDCs are the core courses for a particular discipline. So we want to see attendance and performance in CDCs of first and second disciplines. Because first and second disciplines, why we are calling this? Because in BITS we have a concept of dual degree. So anybody who is admitted in science can opt for a degree, additional degree in engineering, provided he is ready to spend another year with BITS, right? So that's what comes under the concept of what is called as dual degree. Okay, so these are all the things that I wanted to know, and then I wanted to know if attendance in forenoon and afternoon sessions, in which session it is better, and attendance of UG and PG students, whether UG students are more regular or PG students are more regular. And then most popular discipline is choice for dual at different campuses. So all these things I can analyze, right? So I can do a lot of analysis on this, or this is the kind of analysis that I want to do from my warehouse. Performance of dualites versus single degree students. It is typically found that dual degree students are more kind of hardworking. So student registration event. So this is let us look at this process. So when a student comes in for the first time in a semester, right, he has to register. So that is what is called as a registration event. So grain of the fact table would be 1 row for each registered course by the student, and semester. So you understand this. So if a student registers for a course, so he will be like the entries that would be there would be like this. Say ID number, then course number, then semester, campus, and so on, and faculty also. So he registers for a course which is taught by a particular faculty in a particular semester in a particular campus, right? Semester is lowest level available for the registration event. So you cannot register a student for a month or for 10 days. So he has to register for a full semester. Semester dimension should conform to the calendar date dimension, right? So this is the concept of conform dimension. So you can see the attributes that apply at the time and day hour level would not apply when I talk about the semester dimension, right? So that's why we need to conform. And student dimension should have demographic data plus on-campus information like part-time, full-time, involvement in athletics, major, UG, PG, etc. Right? Student dimension should have the demographic data for on-campus students. So student registration event star schema. So the dimensions involved are student, course, term and semester, instructor, campus, and this comprises a factless fact table, right? And this is the detailed registration schema, and you can see here that this particular thing is actually the dummy fact, and this is a factless fact table, the course registration event fact. And you can see the dimensions are obvious. There is a student dimension, instruction, course, and term dimension. So now let us turn our attention to student performance. So here you will need to identify the student, the course, the term and the semester, the instructor, campus, and some dimensions are and granularity, same dimensions and granularity as registration. So because performance also happens once a semester, and so does registration. So they have the same kind of granularity as the dimensions. This particular student performance star schema would have the same granularity as that of the registration process, because both happen only once in a semester. And then another important thing that we need to address here is that how do you model the grade. So grade, say for every row in a fact table there should be a grade, right? So what grade he got in a particular course. So grade to be modeled as a dimension or as a fact, so that is what we need to know. So the grades are like A minus, B minus, and so on, and there is a GPA attached. So this is 10, this is 9, this is 8, and there is also a description, that is A is excellent, right, and say B is good, something like that, right? So there's so it is not just a value, right? It is a set of values where you have the grade name, you have the grade point, and you have the grade description, right? So all these suggest that we can have grade as a dimension, right? And then in that case you'll have to have a grade dimension also here. So student performance star schema. Okay, so I've left this right. So attendance, so let me clear this so that I can draw the schema here. So student attendance, so you will have attendance fact table which is factless. So here you'll have student ID, course ID, attendance, right, room ID, term ID, no, this would be class hour ID, class hour ID. Then what else? Student course student course, what is this, RID, student identifier, course identifier, then room identifier, then the day and hour identifier. What else you need? Faculty identifier, right? So that's it. And yeah, so these are the dimensions that would apply. Okay, and you can see that all these so this is a factless fact table because there are no facts that I can attach to this, so it's a factless fact table. And then all these dimensions would, so this is student, this is course, this is room, this is class hour background, and then the faculty background. Okay, faculty, it is also called as instructor in some cases. So instructor, and then room IDs are also like rooms. Instead of rooms, we call it the facility. So when I say facility, it also incorporates all kinds of rooms where students come for either labs or classes. So this is the typical student star schema, attendance star schema. So dimensions apply that I've told you: day, hour, instructor, and facility, right? So you can see this, and of course campus also you can add, because if you want to do some analysis with respect to campuses, then you need this. And this is the attendance, the student attendance fact table. So I've already explained this to you, so let me skip this. So dimensional modeling concepts that were used in this particular case study included factless fact table. So this is something we recently learned, right? Then we have the concept of mini dimensions, which can be applied when we are dealing with the demographic data of students. Then events that did not occur, like a student not going to a class, so it can be modeled using factless fact tables. And then conformed dimensions. So I'll give an example. So here in this case it is time. So suppose I'm doing registration, so my time granularity will be a term or semester. So if I'm in semester 1, it will be like this, then there will be attributes. Whereas if I look at the attendance schema, so here I look at even the lowest granularity, like the lowest granularity is a day, hour is to be used, because a student goes to attend a class in a particular day and hour, right? So attendance is different, right? So this attendance time, the time that we have in the attendance schema is say T1, and the time that is there in the semester scheme, in the registration schema, is say T2, right? So now you can see that the granularity is very, very different for these two. Okay, right? So it is at the day hour granularity and it is at the semester granularity. So with this, I come to the end of this particular lecture on academic data warehouse. Although there are lots of other things that you could include, but just for the sake of simplicity, I have just introduced this topic. Although we can talk about faculty of facility utilization, research projects, alumni, and there are a whole lot of things that you can do for academics in terms of a data warehouse. So in the next case study, I'm going to talk about banks, right? Thank you.